All right, let's talk about function composition. So given a function f that goes from a to b, and g, a function that goes from b to c. So those are two functions. Going to run out of space here. Two functions, comma, the codomain of the first being equal to the domain of the second. Now, what I mean by that is the codomain of f is the same as the domain of g. Now, given that we define the composition of f and of g to be the function that we're going to call g circle f, like this. And g circle f is going to be the function that goes from a to c, and we're going to send x to g of f of x. Alright, so let's go over a little diagram to see what's going on in the function composition. So we have the set A, and our function sends elements of the set A to elements of the set B, and then our function g, so this is f, our function g goes from B to C. Now, f sends x to f of x, and g, what we can do is take all of the elements f of x to g of f of x. Now, what the function composition, g circle f, what it does is it takes all of the elements x that are in A and sends them directly to g of f of x. So it does the work of f and g in one step. Alright, so let's go over a few examples. Alright, so in our first example, we'll finally be able to justify why we call the identity function, well, the identity function. So we're going to start with a function, an arbitrary function that goes from A to B, and we'll compose the identity function over A with the function f, okay? And this function happens to be equal to simply f. This is why it's the identity. It's like adding an integer n plus 0, we obtain the same integer n. So we would call 0 the identity of the addition operation. The operation of composition, its identity is the identity function a. Now, the reason that this is the case is that if we take an arbitrary element x that is an a, then we have f circle the identity of x. Now, what does this equal to? Well, we have in our definition, it sends x to g of f of x. So this is going to send x to f of the identity of x, like so. Now we know that the identity of x is x itself, so we're going to obtain f of x. So those two are equal right here. And since we used an arbitrary element x here, this means that those two functions are equal. If we wanted to switch the order, have f as our first function and then the identity function on the left side, we would need to have the identity of b on b. And the reason for this is, in the first case, we have a and the identity of a, and then we have f that sends a to b, and this is our composition. We have f circle the identity. In our second case, let me just bring that down a little bit. We use f first, that sends A to B. So this is our function f. We then have the identity, so the domain of the identity has to be B. So it needs to be the identity over B, like this. And our composition is the identity over B circle f. This is going to be equal to f as well, and for the same reasons. This, by definition, is the identity of f of x. Now, if the identity of B sends any element y in B, it sends it to itself, so we'll simply obtain f of x. Now, for a slightly more interesting function, we'll talk about the projection of the space R3 onto the plane xy. So we take a triplet xyz, and we send this to the pair xy. So it sends the space x, y, and z. It sends this to the plane xy. And we're going to have the sum function, which takes a pair of points and sends it to a real number. So we have x and y, it takes a pair and it sends it to its sum. The function composition of S circle P, this would be the function that starts from the domain of P, so R3, and sends it to the codomain of our function S, our sum function. We have a set of real numbers, and it sends the triplet xyz to simply S of P of xyz. And what this is equal to is simply S of x and y, because P here sends xyz to x and y. Now S sends xy to the sum of xy. Okay, I might need to put some brackets here, if you insist on having them. Now, what would happen if we would change the order of those two functions and try to talk about P circle S? Well, it wouldn't be coherent at all. In fact, S would take R2 and send it to R. So this would be S. And then we would try to use P to send R to R2. But the problem is that we defined P to be a function that goes from R3 to R2. And now we're trying to compose S with P, right here, S with P. And this means that P takes a real number and sends it to R2. So this right here doesn't work at all. This is why in the definition I specified that the codomain of the first being equal to the domain of the second. This is very important. So every time you're dealing with function compositions, you need to be assured that the composition actually makes sense. The codomain of the first function has to coincide with the domain of the second.